Okay, welcome back to the last session of the 5G Global event. Although, of course, this is a joint session with the EuCNC. We're trying to have a sort of soft handover from the more regulatory things to the more project-based things. And we now have the session on 5G KPI measurement, and I'd like to welcome to the stage Mr. Maurizio Cecchi, who will be moderating it. Thank you.
Thank you, Colin. Thank you to everybody. It's my pleasure here to moderate and introduce this session. And as you know, we are working on pretty technical and scientific stuff, how to measure KPIs, 5G KPIs, so advanced performance. But the motivation is not technical. There is only one reason why we pushed for this kind of initiative, and could be shortened in one word. We need to do this because of business. If the clients, the future clients, the people that will use 5G don't understand really what is the benefit and really the better performance, but in real life, in real environments, I mean, all this initiative around 5G will fail. You know, there are many announcements from lab tests, from vendors, operators in many regions of the world. But now, in this period of transition from research to commercial, we have really to understand the benefit in terms of performance in real environments. So, of course, this will be a task of all the presenters to try to highlight this part that should bring the reality inside this arena and not only lab results. So, as you know, my name is Maurizio Cecchi. You know, most of you knows me for my Telecom Italia initiative, working now in one institute dealing with technology transfer. But now I am pleased to present the speakers. And basically, rationale that we had in mind is this. From many initiatives in Europe and from many projects, there was joint groups, let's say supported by the 5G public-private initiative, and a specific group really to find a common approach and methodology to measure KPIs. This produced a white paper that is available on the website of the 5G PPP. So basically, the first three speakers are the leaders of this exercise. Harilos Kumaras from Demokritos is assistant professor and chair and co-chair of this group. Panayotis Domestikas from Wings, professor from Piraeus Industry, very active in this kind of initiative. Andrea Cattoni is also co-chair of this working group on performance. And then the rationale was to invite other regional areas to give their ideas, comments, and suggestions, because of course it's not a matter only of Europe, but is a worldwide challenge. So with Xinhui Yang from ZTE, Do Young Kwak from KT Corporation in Korea, and Takahiro Nakamura from Fujitsu. So please, Harilos, would you please start?
Good afternoon. My name is Harilos Kumaras. I am Research Assistant Professor at the National Center of Scientific Research Demokritos in Athens, Greece. We are the coordinators of 5Genesis project. It is an ICT 17 project, as you know, that deals with designing, developing, and delivering an experimental platform where tests on 5G will take place. So the KPI formalization is very important in this work because currently we have a need. The need is that we build the 5G networks, the platforms to perform experiments, to offer to the verticals the option to test the services, to test the components, to assess the KPIs of 5G. However, we need a way in order to reassure that the results are feasible to make comparisons among the different platforms. So for this reason, we, in 5G PPP, we have created a working group that deals with it, and we have started to work on defining a formalization method for the KPI assessment. Just a few words on the 5G PPP. As you know, there are many working groups currently active and running. Among these working groups, the KPI working group already existing before, and was the working group dealing with the definition of the KPIs, the values of the KPIs, but it didn't include any work on defining a framework for defining the experiments for measuring the KPIs. So recently, a new working group came up. It is the Test, Measurement and Validation Working Group, which has as the main scope the definition of the whole framework for the experiment execution, description, and etc. So my presentation deals mainly with these initial results of this working group. We are just in the beginning, so we have some initial results to share with you. So the first issue that we had to deal with was the definition of the experiment. In order to agree, all the groups and all the platforms of 5G PPP, to agree on a common understanding what is an experiment and how we define it. So we selected a modular form and an hierarchical approach for the experiment. So each experiment, actually, we map it to a specific metric. So we explain that an experimenter actually is interested to a metric when we test a specific service on top of a 5G facility. Now, the metrics are strictly dependent on some KPIs. So depending on the technologies that realize the specific facility, these KPIs define specific KPIs which in turn affect the metric that is going to be measured. Finally, each KPI, each target KPI is related to a test case and from different scenarios where depending on the slice configurations, this test case affect again the KPIs, which in turn affect the metric that the experimenter is interested to measure. So this is the formalization that we have tried to follow. Experiment mapped to metric. The metric is affected by the KPIs of the facility. The KPIs of the facility as affected by the test cases and from the slice configuration that is used for the specific experiment. Okay, this is the overall description, let's say, the concept, how we have tried to formalize the experiment. Now, in the practical way, in order to be able to feed our systems with specific descriptor files, we have defined a group of descriptor files for the experiment, for the target metric definition, for the test case, for the scenario, and the slice configuration. So, as probably you have watched in the previous presentations and across the different workshops, the three 5G PPP facilities, 5G Vini, Eve, and Genesis, all use some kind of experimental portal where the experimenter is able to define the experiment. These portals produce some descriptor files of the experiment, which actually will be in line with the descriptor files that we are developing in TMV working group. So going through this, the most important descriptor file is the experiment descriptor, which include a high-level overview of the whole experiment. So includes the test description of the experiment, the target metric, the test case, the scenario. So actually, we can say that is the overlay descriptor of all the rest that will follow. Then we have the metric descriptor. Actually, this is the metric that is directly mapped to the experiment that the vertical industry want to execute. Here, in order the experiment to be valid, we need not only the metric, but we need also to map at least to one test case for a specific scenario and the slice. So once we have defined the metric, we need to define at least one scenario description. What is the difference from the metric? The metric is the definition, the theoretical definition, let's say, of what we want to measure, independently of the facility that the experiment will take place. So we don't consider the environment, we don't consider the facility, we don't consider the technology. It's the theoretical definition, for example, that I want to measure the latency. Now, in the scenario description, we complement the metric with the system itself. So we're considering performance perspective related to the facility. For example, what is the frequency band? What is the setup? It is standalone, not standalone. What is the technology? It's 4G, 5G. So all these details define and form the scenario descriptor template. So having well-defined now the metric, what I want to measure in theory, the scenario, what I want to measure, depending on the underlying facility and testbed. Now we are moving to the slice configuration and the traffic description template. These are the two last templates that I need in order to deploy my experiment on top of the specific facility. So in the slice configuration, I provide details about the VNFs, PNF initiation associated with physical machines. I will include the VNF descriptors, the networks to be used, the location at which NFVI POP, the deployment and realization will take place, and etc. And finally, the traffic descriptor file, I include details about the traffic resources, the sources that we'll use to emulate specific traffic patterns in order to make my experiment more realistic and to be possible to stress the system under different conditions. So this is the family, let's say, of the descriptor files that actually formalize the whole experimentation process. This is the way that the TMV group builds the whole formalization, and this is the way that the three projects, 5Genesis, 5G, and 5G Vini, through the experimental portals, build the whole experiment experience, let's say. So now there is an opportunity for 5G experimentation. The three projects now this month complete the first year, so the first release of the platform becomes available, and vertical industries, SMEs, service providers, component developers are invited to explore the opportunities that 5G offers and to run their own experiments on top of these facilities. As Maurizio described, all this formalization framework already has been reported in a white paper that TMV has produced. This paper, the white paper, is available at the 5G PPP webpage. for your convenience, I have provided also this short link. You can use it to download it and to have all the details of the templates and the descriptor files that are used for formalizing the experiments and the KPI definition. Thank you all for the attention. $11 minutes.
Thank you much. Harilos, just to say that please, we should keep then all the questions in the last, at the end, so there is the panel, all the speakers will be here then to answer to your questions, so to keep on time and then to leave the place for the panel. So now I would like to invite Panayotis Domestikas from Piraeus University. He's professor teaching networking management there, but was also invited because he represents also the business side of what I said before. He's founder of Wings and Intelligence that of course has this crucial problem to demonstrate to clients how this performance could be achieved. So please, Panayotis.
Nice introduction. Yes, as Maurizio said, I'm going to take, let's say, a description. I'm going to describe a problem which is actually, of course, a subset of all the work that is being done in 5G, in which I work, or also in the group that has been defined in order to coordinate the three platforms. So the keywords that I would like us, let's say, to focus on are the concepts of validation and of performance diagnostics for vertical applications. So I will provide a motivation on why we address this. I will, of course, describe on how one can experiment and actually solve the problem, solve the motivation, achieve, let's say, the goal, and also describe some future plans. So what is the motivation? 5G will be successful, as we know, if we manage to attract certain verticals. But verticals, in order to be attracted, we have to convince them on the benefit they will need to pay. So we have to convince them on what will be the added value that they will obtain through these new networks. We know, of course, but actually going out on the business world is a different story. So the aim here would be to deliver a tool or a set of tools that can be at the right level of abstraction, and through these abstractions we could show to the vertical the actual, let's say, performance obtained, and also the reason why it is obtained, of course at a proper level of detail, and also to conduct diagnostics. By diagnostics we have defined, and we mean to suggest also improvements. If something does not go well, how can we improve it? So let's say this is the main motivation. How can we provide to the vertical a set of tools that can be, let's say, useful and at the appropriate level of abstraction? Timing, as we know, is everything. So through such a tool, we need to be, let's say, we need such a tool today, because already today we have started, let's say, the experimentation. People are hearing a lot of stuff about 5G, so we have to be, let's say, in place to have the appropriate tools in order to support our arguments, generate insights towards the verticals, but also enable informed, as we call them, informed business decisions from the vertical side, but also from the operator side. A key issue that I would like to highlight is that we are, from my side of the talk at least, we are not talking about a detailed network, let's say, monitoring tool. This is covered by the big companies. There are excellent companies like Keysight that do this, and also operators are experts. But we are talking about a tool that could focus a bit on the vertical side and could also, let's say, have some mappings to the network performance in order, of course, to enable the diagnostics that will come later. So, a bit more detail. We have the KPI list and we have the KPI targets even from the requirement work several years ago. We have to define measurement methods, of course, in order to be robust in what we will measure. We have to have tools for generating the validation conditions, conditions that are credible and are also close to what the vertical has to, let's say, will experience. And also we have to have variables that can reproduce the experiments. Of course, each experiment needs to be reproducible. So, first step in the direction, a bit more general, not only related to the validation, but starting, let's say, from the beginning. First of all, if we are talking about 5G, 5G employs 2 or 3 tools that will be used and offered to the vertical in order to specify the experiments. One example that I can give is an intent-based tool in which there will be a very high-level description of the service and of what the vertical wants to do. And this will be then translated by the underlying mechanisms towards, let's say, experiments, towards test cases, and really fine-grained and technical stuff. So there you see the process. I don't have the time to go through it all, but if you can see, it goes from high-level, let's say, description into more low-level aspects, and from virtual functions to actual physical resources that will need to be engaged. Having specified the experiment, we can go to phases 2, 3, and 4, in which we can, let's say, employ various tools in order to generate the tests, have the testing tools, conduct the tests, and also capture, let's say, the data that is generated from them, and also conduct the analytics, which eventually will lead us also to the diagnosis of what went wrong or what went well and why. In terms of system architecture, we have defined the testing framework that you see on this slide. We rely mainly on open source components like Kafka, for instance, and there are Kafka streams that are collected from the various parts of the network, which can be, of course, the element, but also something more, a management system that exists today. And then they are processed in order to conduct the detailed analysis. Beyond having, let's say, the ability to collect, we are also working in the area of defining test cases and also having a scientific process to a number of realizations of each experiment, and also of a number of tests that will be done concerning each KPI before progressing to the validation. So, bottom line, let's say that the vertical will have the task of specifying the service, specifying, let's say, what is the interest, but then there is a lot of work that will be done below on the back end, the underlying layers, in order to translate all these requests, reserve the resources, conduct experiments many times, and also focus on the target KPIs. This leads us to this situation with respect to 4 or 5 categories of tools: the traffic generation tools in order to generate the conditions, the KPI monitoring tools, the visualization, and also the validation, which means, let's say, the insight and also the diagnostic part. What went wrong, or how can your experiment be improved? Let's go a bit more on the diagnostics. We see here a process that we have defined and we are currently implementing, and we believe that we will be able to show in the next 6 months. It concerns the deeper KPI analysis. It has the anomaly detection part. It has a problem root identification, and then some optimizations in order, let's say, to try to switch certain things in the underlying infrastructure in order to improve the performance. So, as future plans, as you can see here, we are, speaking also of Wings, my company, we are working with various verticals. So, of course, this interaction will continue in total from 5G PPP and also from project partners in order, let's say, not now to, we have also perhaps some work to do to refine KPIs and to refine the procedures, but the actual problem now is to attract them into making, let's say, through especially such projects, the experiments, and then progressing to further business relations. So this is ambitious and essential next step. And also, let's say, to develop in parallel this testing and validation platform that can be offered to them during the experiments and hopefully at the end of this phase as a tool that can generate additional business. So thank you very much. I think I'm okay with respect to the time also.
Thank you, Panayotis. So now we hear the co-chair of this working group that was presented, and also representative of KISAID. KISAID, you know, is one of the largest corporations in the world that working on measurement. So please, Andrea, your presentation.
Good afternoon, everybody. I would have liked to come here today a little bit more sharp, a little bit more shaved, as you can see probably from the camera up there, with better clothes. But unfortunately, because this is a very critical event, but I decided to use a kind of common provider for my transportation, and the nice thing that I packed were somehow lost and arrived late at destination. So that's one of the reasons why for 5G, when we have critical applications, we don't want to lose luggages in transit. We want to make sure that the verticals get exactly the packets in time. And in order to do so, we need to do testing. One of my previous colleagues was used to tell me that we can only improve what we can measure. And that's critical, because without this concept, we are not able to verify and validate the promises we make for 5G. For this reason, in 5G PPP, we have decided that it was maybe the case, given the fact that we are now in phase 3 projects, to collect all our brains together, collect our experiences, and try to have a group fully dedicated at understanding, first of all, what are the technical KPIs, going from a generic 1,000 times performance to something tangible, something we can actually measure, and make sure that we all together align on how to do these experiments, these tests, and formalize them. And I need to thank all the people that contributed so far, because in less than 6 months, we managed to have some agreements that you are seeing today and a white paper out. And it's not only the ICT 17 phase 3 projects, Vini, Genesis, and Eve, that have contributed, but we also collected the experience of other phase 2 projects like Tango, Transformer, Picture, 15G, and Matilda. Thanks to all these people, all these collective experience, we are actually today in a stage where we have agreements on how to move forward. That's because how we are dealing with networks changed over time. In the past, traditional hardware-centric networks had very clean stages between R&D to operation, where testing and monitoring were somehow fairly well defined. Software-centric networks like 5G is a little bit more complicated, and it has all these kind of constant onboarding of VNFs that makes the process even more complicated. We need to make sure that in all these processes we don't lose track of the performance and the vertical. For us, 5G is a pyramid that starts with the technologies like access or the data center fabric, the underlying networks. On top of that, we need to have an NFVI infrastructure, an orchestration layer, the VNFs that do the telco processing, and finally on top we have the slice or end-to-end service. Normally, the approach that we would like to have is a bottom-up testing. We start from the individual components and we climb up. Nevertheless, a priority for the test measurement and validation working group was not to start in this direction, but to start from the top, because the top is what is currently missing today. All the rest, we have standard bodies currently working on defining test specification from those. But the top, the ones that looks at the vertical, that's missing. And that's where we need to fill the gap. One of the first agreement that we made in the test measurement and validation working group is to sit down together in the same room, face to face, and start looking at what are these practical KPIs that are going to validate the promises that 5G has made. And believe me, it's not easy. People would think that there are millions of KPIs well-defined out there, and then you start looking at a lot of them, and you see that there's something not right, something missing. That's because in the standard bodies, they define what is important for their specific technology component, and if you go to entities like NGMN, they give looser definition because the implementation is left somehow to the different parties. We cannot afford that. We need to sit down and define exactly the measurement points, exactly what is the formula, and exactly how to proceed, how to experiment with that. And so far we have defined a small set that we call the core KPIs that will be expanded over time, that we are formalizing. And there is a portion that we call technology validation. And that's because you can measure those only in specific testing. You need to do active testing to measure those. There is another portion which is more related to SLA and service level agreement that can be measured in active testing, but can also be somehow adapted to be measured in monitored operation. But when do we need to do these testings? Well, there are different phases, and normally we have what we call system validation. So an operator who needs to deploy a network, we need to do testing over there. There is onboarding, which is somehow a constant operation. You need to do testing over there. But there is also someone who designs service. And when a new customer comes, has a different requirement, you also need to check whatever you are designing, even if you are at the very top level. Or at the service rollout. Every time you deploy a slice for a critical customer, you want to make sure that that slice that you have rolled out is actually performing. That leads a little bit to something that is, we can maybe borrow it from IT. And it's the CI/CD NetOps cycle, where each portion of the cycle starts from a lab or from a cloud sandbox, and it circles around until you get to a live network with real users. And then the cycles goes back, because as soon as you modify something, you need to go back to square one in the sandbox, verify it, and back. We are talking about software. Software is not like the hardware where we could make it very, let's say, reliable and secure. Software is a little bit more prone to errors. For this reason, we need to do this constant circle. How to do that in a way that is not too costly for operators or vendors? Well, we are working on a concept that is called test as a service. A fully automated system that allows verticals, mobile operators, network equipment vendors to have an easy access to testing, but also include this testing in their CI/CD pipelines. And that goes from test case repositories, test cases that in the TMV we are currently in the process of discussing, down to how we do with the REST APIs, test and measurement tool. This is, in a nutshell, the kind of high-level architecture that my previous colleagues have presented. Thus, how does it impact the pyramid? Like that. It's basically the ring that rules them all. It's the system that can take any piece of the 5G architecture, take any tool, automate that, and make sure that all the pieces interact together and play well. We go from layer 2, layer 3 traffic generations, performance testing where we bomb the network, up to conformance, performance, and security testing up to the service. TAS is the system that needs to control them all. So the TMV is a baby born. So we did some progress, we did some initial steps, there is a lot to be done. And I'm happy with what we are doing right now. And we have some few things done, like the KPIs already defined, and we are specifying more. We invite anybody who wants to contribute to join and enhance that list of KPIs. But in the end, 5G is a complex system. There's only one way to make sure that everything works and we are able to digest it, one bite at a time. Thank you.
Thank you very much, Andrea. So with the presentation, the three presentations, I hope you had a good glance of these efforts that is done inside the 5G PPP program. That basically is the vision from the European industry and academics at present. So, before asking the representative of the other regional world areas, is important to highlight what was said by the three presenters, that this kind of platform for testing, so 5G, EuCNC and Vinny, are open. So if you have specific experiments, you can go there. All these projects have portals, so you can go and ask to make extra experiments, even if you are not already inside the consortium. So now I would like to invite Xinhui Huang from ZTE. He's Director of the Wireless Standardization and Industrial Relationship. Please, go ahead.
Okay, thank you, Maurizio. I'm just presume I pronounce this correctly. Right. It's quite an interesting name. And good afternoon, ladies and gentlemen. First of all, I will thank the meeting organizers for this great job they did to make this big event happen. That was good. Okay, thank you. And by the way, thank you for inviting me. You know, it's been the second day of this event. We've been talking about a lot of things, and this is the last session of this event. You know, with all due respect to the previous speakers, okay, they did a really good job. It was fantastic. But you know, some says, the last one is best one. So let's enjoy this last course with some secret recipe, which is KPI, Key Performance Indexes. You know, we've been discussing about something like the immersive interaction, the AR, VR, and plus one of this really impressive show that took place yesterday. It was something like a holographic show with two parties in conversation being involved. One is locally, one is remotely. That was fantastic, good. But you know, all of these good things require a technical support substantially. And a KPI, or say, a set of most prominent KPIs, is going to evaluate the system capability. It's going to see how well a 5G network works. And this eventually brings us to this rub meets road. See what's going to happen. Okay? Conventionally, we're going to have a ITU identified 8 KPIs for this 5G. I presume people have been knowing this for years. I won't go through this one by one in detail. But I want to just pick up two things. One is this peak data rate, which is 10 gigabits per second. Another one is something like 1 million. It's quite an impressive figure, okay? 1 million connections per square meter, okay? See if 5G can reach these commands. And next one, things from this slide, I'm going to share with this group outcomes of 4 trials took place in the country I'm living in, which is China, and done by the company I'm working for, which is ZTE Corporation. This is the first one. This was simply a test led by MIIT, in short, MIT, in Beijing. It was based a phased approach, step 1, step 2, and step 3. This is basically the step 3 result of this test. I still remember, one comment raised by one of the speakers yesterday, which is Mr. Don Warren from Samsung. He said, one of the drawbacks to have these figures on a presentation is it's required easily be obsolete. Yes, it happens as well. You see the top left, this table, this was done by January of this year. On this table, you can see some vendors, they're not able to complete all these trials. But now I believe, I'm 100% confident they have been done everything. Okay, so basically, this was a test focusing on 2 sides, standalone and non-standalone, focusing on a couple of measurements. Next one, peak data rate is something quite interesting. In this case, as you can see on the left side, top left, that was basically the layout of this trial field. We have a base station mounted on top of the tower, and you have a van. Put your mobile phone inside of the van, and it runs at a speed of 40 or 60 kilometers per hour, which is quite a typical, velocity in rush hour for the urban scenario. And then you're going to test some quite conventional figures, which are, the peak data rate for cell, the peak rate for single users. And in this case, you can see a couple of numbers. Basically, you can see, for instance, the circle in the middle, which is the second circle, which is around 13 gig per second, which is the downlink throughput for this NR cell. It's much better than the one identified by ITU, which is 10 gigahertz per second. And user experience data rate. This is something we can really experience in our real network by our real mobile phone, which is not something like a theoretical figure in lab. No, it's definitely not. And in this trial, we did this as well. You can see the circles on the bottom of the slide. Basically, we're doing something like you're going to check this downlink throughput, uplink throughput, and on the right side, there was quite an interesting side effect of this trial. We did some handover in between LTE and 5G new radio. And it turned out some quite interesting figure. You can see on the right side as a circle, you have around 500 meg per second, and you have around 200 megabits per second for this for this uplink and downlink figures. But on the right side, you can see the circle. This was something like LTE. It was a little bit poor. You can see basically 5G outperforms LTE at almost 9 times on both uplink and downlink. This is something we got to be confident on the 5G technology. Connection density. You see the number in the middle? It's around 2 million, which is just almost double the figure of this 1 million per sec, 1 million connection densities per square meter. This was done by some quite fancy technology, which is called NOMA, non-orthogonal multiple access. You can preliminary superposition more users on the same radio resource. For instance, a radio block. You put 3, you put 4, 8, or 12, it's up to you. And thanks to the advanced technology of the uplink receiver, they can possibly decode all these superposition users on the same resource separately and clearly with accuracy. And then this helps us to make this around double number of this one identified by ITU. This is second trial, took place in Suzhou, which is a city 70 kilometers away from Shanghai, in which we're going to have our next 8th Global 5G event next year. And in this one, it was quite typical thing, and you can see we operate this at a 3.5 gigahertz band in a standalone manner. MIMO is a must. So you can see the 64 something, right? We have 64 antenna ports over there, and on the downlink side, for instance, on the mobile side, you can see the 26 dBm power, which was identified by 3GPP and specified by 3GPP for this new 5G mobile phone. With all this setting, we did some experiment, we did some trial to try to figure out something on this coverage and capacity. On the top of thing, you see the coverage. Actually, we are doing some, let's say, comparison in between 5G operating at 3.5 gigahertz band and LTE operating on 1.8 gigahertz band, which is quite a normal case around the world. In this case, we just identified something really, really encouraging and really interesting, which is basically on the uplink side. At the cell edge with maximum distance, we can almost achieve the same data rate in both 5G and LTE. Oh, this is quite interesting. You know what? Normally, operator considers something. I'm going to deploy my 5G at 3.5 gigahertz, which is a globally harmonized band, which is called C-band. It's good. But technically, theoretically, the propagation mode of 3.5 is much worse than 1.8. So the question came out, looks like, will my uplink coverage be compromised by deploying this 5G on 3.5? This is serious. And then the result simply says, take it easy. But why we can be so confident? Just say, take it easy. Thanks to MIMO. I have to say, thanks to MIMO. You know, with this, quite fast technology, you have a extra diversity gain by having more antenna ports. This is on uplink. And on the downlink, you can still see a very good, side effect, which basically comes from the beamforming and the beam management techniques. In this case, if you can tune the downlink direction on this, the beams quite accurate, and then you could possibly reduce the level of signal versus noisy. And then it helps for decoder. It's quite clear. With these two things, and then we'll achieve this almost same uplink. The third one, a trial took place in Beijing, was same operator. And you can see on the top left side, which was something on this uplink and downlink performance, focusing on single user. But on the right side, exactly the same, except one thing. This was on a cell level, which means we're going to calculate all things correspondingly for different users and put them together. Something needs to draw the attention of this group is on the top left. As you can see, the longest block, which stands for the 3.2 something gigahertz per second for a single user, which is much less than the one identified by ITU, which was 10, right? But in this case, pay attention. In this trial, we put 12 mobile phones inside, and every mobile phone was equipped with on 8 streams. Just consider, if we put on one mobile phone inside, and we just equip this mobile phone with more capability of streams, and then the 10 gigahertz per second is not a dream. Still the same operator, same scenario, and something really interesting is on the top one. I believe we don't need to elaborate a little more on the bottom one. This was basically a comparison between LTE and NR on downlink. The red, okay? The red block stands for this performance of new radio, 5G, and the little lovely blue thing stands for the LTE. It's quite clear, you have a 100 mix bandwidth, and you can definitely outperform LTE. It's for sure. But on the uplink, this is something quite interesting. Do you see those lovely little yellow points? This stands for the receiving power level at different test points. For instance, from point 1 to point 13. For example, on the most right side, you can see the point 13. At this point, the receiving power level is quite, it's quite weak. It's around minus 120 dBm something. This is, it's definitely not acceptable. But at this case, you can see the uplink performance in terms of data rate, almost same in both cases, NR and LTE. And you can see on the left side, the most left side, this is 0.1. In this case, the receiving power level is really, really encouraging. It's around minus 30 or minus 70 or minus 80 something. It's really encouraging. At this case, the NR outperforms LTE at maybe 4 times, right? 4 times. This is something we did in Beijing for this operator. The next one, the indoor penetration. I believe, in most cases, we stay in the indoor case. Home, office, stadium, cinema. We enjoy the radio coverage, the wireless services inside, just like we did right now. And normally, the contemporary building was built up with a technology called something like glass curtain wall. In this case, we just pick up the typical glass curtain wall structured buildings, just like, the hotel we're living in, the Malia, the hotel was just exactly the same thing. And then we pick up something like this hotel, and we did some experiment on different levels. For instance, as you can see on the left side, 2nd floor, 8th floor, and the 16th floor. And you can see this blue and yellow, let's see, yellow curves. The blue one stands for the 5G case. The yellow one stands for the LTE case. And you can see in this case, almost in every case, 5G outperforms LTE, that's clear. But on the right side, on the top right, the same figure, but this was on uplink. Something very tricky is, I have no idea why my colleague made this thing just in opposite. In this case, the blue curve stands for LTE. The yellow one stands for NR, okay, just in opposite. But in this case, you still can see the difference in between LTE and NR. Basically, we can say in a simple word, NR, 5G new radio, outperforms LTE pretty much. This one. Okay, this basically brings me to the end of my presentation. This is something much more interesting. It's like a efficiency, especially energy efficiency. I believe this concept is well known by every guy. But something we really need to think about is, from previous slides, we've been learning that, okay, with this 5G technology, we can accept this excellent performance. It's for sure. But the question came up into my mind as a vendor to our client is our client willing to operate a 5G network with excellent performance, but at the cost of huge bill of electricity, which is definitely not acceptable? This definitely inspires us to keep proving our technology in terms of energy saving and efficiency improvement. For instance, on different levels, you can do this on the product level, do something on chipset, or on power amplifier, and you can do this on network level. Let's do a little bit, go through, okay? And then you can see the chipset. For instance, we have a very large chipset called DPD, digital pre-torsion, which was some baseband things, okay? It helps to do some baseband, processing thing. And then by involving your technology from 40 nanometers to just 7 nanometers, some more advantage you used, some more power efficiency you will achieve. It's quite straightforward. And then, for instance, the power amplifier, okay? You're looking for a quite better design for this new power amplifier, and you're looking for some new material, which is much more advanced material, which the power amplifier is made of. And on this network level, for instance, you can do some traditional way. Okay, we'll shut down some carrier in case if there's no users. It's quite straightforward. For instance, we'll shut down the carrier which in a base station covers a shopping mall in the middle of the night. It's quite clear. Nobody will be in there in the middle of the night except the rats. But can we think more and dream bigger? For instance, we do something on this channel level. If you did this, congratulations. You got 10% more of the power saving. And then keep improving this. Do this at a symbol level. It's a bit complicated, okay? You need to consider this quite clearly and sophisticatedly. And then you have another extra 5% of this power saving. This is money. This helps our client to fulfill their investment. So this is something we're really considering. And with this slide, that brings me to the end of my presentation, and thank you for attention. Gracias. I was hoping, my Spanish is as good as my French, which is much better than my English. Thank you very much.
Thank you very much for presentation and also the flavor of the first real data that are coming from what is not really lab experiments, but they are really field trials, is what is needed by really the telecommunication industry worldwide. So thank you a lot. So now we have the point of view of another important regions, South Korea, from KT Corporation, that you know are one of the largest corporation in this field. So Do Young Kwak, please, your presentation.
Thank you, moderator, and thank you for having me. My name is Do-Young Kwak, and I work for KT Infra Laboratory. Actually, I tried to find a slide cover page written in English, but I couldn't. The right side, it is the catchphrase of KT 5G. It means your superpower, KT 5G. Today, I'm gonna talk about the measurement of KPIs in real commercial 5G network, which give you a superpower. My talk consists of two parts. Firstly, I will introduce 5G status in Korea, but as you may know, unfortunately, many speakers from Korea already dealt with the Korean 5G status yesterday and today, so I can cover it very briefly. And in the second part, I will show the KPIs and the target values. This is the 5G roadmap in Korea. There were 3 major milestones in it, and KT played key roles in all of 3. First one is trial services in the Pyeongchang Winter Olympic Games in February 2018. KT made the trial specification and completed trial service in 28 gigahertz successfully. The second one is the spectrum auction held in last June. KT paid the money for it, very big money. We spent more than $1 billion total for mid-band and high band. Finally, the commercialization. The commercialization is carried out in 2 steps. In the end of last year and early of this year. I will skip this slide. This shows the KT's 5 new vision, which is denoted in the MWC keynote speech by the KT CEO. And KT considers 5G not merely as a network technology or infrastructure, but as a platform to give some valuable benefit to the individual and industry and society. This is the status of 5G coverage in Korea. KT started deployment of 5G base station end of last year and rolled out more than 30,000 base stations in nationwide. The right figure shows the 5G coverage in Korean Peninsula. And we have a plan to cover 80% of operation and data traffic by end of this year. Now let's turn to the topic of KPI. As you may know, 5G had 3 major usage scenarios, and KPIs and target values is defined with considering, oops, considering the new future emerging services. At this moment, we are focusing mainly on the EMBB and your LLC services. So the KPIs, also we focusing on the improvement of peak data rate and obtaining the high reliability and low latency. Various organizations such as 3GPP, ITUR discussed the 5G KPIs as shown in this table. Oops. And this is, most of these values are theoretical value, and it will play an important role to determine the IMT 2020 standards. In these KPIs, I will deal with the peak. What's happening? I will deal with the data rate and latency, which is, excuse me, I didn't click the button, but and the peak data rate and the latency, which is you are very interested in, I think. At this moment, KT provided the 5G service, commercial services with 100 megahertz bandwidth at 3.5 gigahertz. So the left graph shows the theoretical peak data rate in system side and user side with the existing base station system and mobile devices. With the 20% of DL-UL ratio, the UL peak data rate is very, very lower than the downlink data rate. And real measurement value is degraded than the theoretical value. The right figure shows the measurement result. Measurement result of the KPIs in the one coverage, base station coverage, which is carried out by my 5G smartphone a few days ago. In the weak RF strength, signal strength point, the downlink data rate is 130 megabps and uplink is about 10 megabps. And the ping latency round trip delay is about 22 milliseconds. But in the strong RF, situations, the downlink data rate goes up to 500 megabps and uplink data rate also goes up to 60. Also, the latency lower to the 12 milliseconds in RTT. So one-way latency is about 6 milliseconds. Now, the latency. The end-to-end latency, what happened? This laptop wants to finish my presentation so early. Yeah, this end-to-end latency consists of these components. As you can see, the app and server latency is bottleneck of the total end-to-end latency. So KT come up with deploying 8 edge centers in the nationwide. The Korea is not a big country, but with the 8 edge centers, we can provide less than 10 millisecond latency to every user in everywhere. As you can see in the previous slide, the ping RTT latency is about 12 milliseconds. So with the deployment of edge center, we secure the low latency less than 10 milliseconds. But in the operator's viewpoint, the KPIs related to the 5G inherent feature is important, and the KPIs related to the robust operation is more important. So we focused on the monitoring KPIs related to the operation in this table. And we are monitoring the parameters, many parameters, to check the 5G system working well or not. In the right side, we monitoring a lot of parameters, and we want to secure the robust operation even in the failure situation with the root cause analysis. And I'd like to conclude my presentation with introducing AI-based 5G zone. Oops. AI-based 5G zone, including the functionalities of network KPI diagnosis, self-optimization, and self-healing furthermore. So we hope that AI-based 5G zone help the complex 5G operation making easy and enhancing the 5G performance in real situation. Thank you very much for your attention.
Thank you very much for this view from KT Corporation. So, last but not the least, presenters is from Japan, is Mr. Takahuro Nakamura from Fujitsu, acting chairman of the technical committee of 5G MFs. Please.
Okay, so good afternoon, everyone, ladies and gentlemen. Well, it's my very honor to be the last speaker of the last session. And, oh, by the way, thanks for the kind introduction to me. So my talk is about 5G KPIs in real terms. And, well, by the way, I should be careful. If I'm running out of time, I will be executed by the moderator as well as the audience. Anyway, let's get started. So, well, my original intent was to provide something useful materials to the panel, which will talk about the KPIs. And having heard the previous presentation, well, okay, anyway, let me continue my talk. But this is the requirements of 5GNL, and as has been discussed already, I wouldn't go into detail, but my talk will be somehow, I believe, somehow useful how to elaborate actual KPIs from these requirements, or how to establish the reasonable SLA with your vertical players. I mean, I have read the very exciting white paper from 5G PPP, but maybe my talk is something located on a previous stages, how to establish actual or reasonable KPIs or reasonable SLAs. So maybe that would, let's see what happens. Then, before going into detail, let me talk about something surroundings, in this case, communication traffic situation in Japan. So, in left-hand side, you can see the traffic trend in Japan. This is our published statistics by our government, Japanese government, regarding fixed communication traffic, either in uplink, downlink, or mobile traffics in uplink, downlink. And if I convert this vertical axis into the log scale, you can see that one in the right-hand side. Downlink traffic in our mobile communication traffic increases by 10-folded in 6 years. It's a quite large amount of increment. And this is, because of that, it's a very urgent subject, and to me this is one of the biggest motivation to elaborate 5G system into the market. And if I turn to convert it into an annual growth rate of traffic, you can see that one in your left-hand side. So while the increasing rate of fixed communication traffic is rather stable, these are red line and blue line, but surprisingly, increasing rate of mobile traffics, either in downlink or uplink, is decreasing. And well, maybe the operator would know, but my personal interpretation of this one is, this is not because the market demand is to the mobile communication system is saturating, but I think this is because the upper limit of the capacity. So I believe, I can imagine every operator pay every effort to cap this capacity or traffic to keep in their upper limit by introducing, say, flat rate services with a certain volume limit, or utilizing wireless LAN to allow traffic offloading or something like that. So if that's the case, I think we have a good chance to enlarge the market demands by introducing new technology, in this case 5G radio access technology. Then the other observation I could make is the right-hand side. It's an traffic share, mobile traffic share to the total traffic, including the fixed communications. And well, in recent years especially, you can see the big growth in the uplink mobile traffic. That means, well, maybe we could continue to monitor the situation carefully for the time being, but one of the situations being happened in Japanese market is people are using mobile traffic in uplink more and more, maybe thanks for the SNS, such as YouTube or WeChat in China. Maybe they have the same situation, I think. So the other point is how to improve the uplink, or how to cope with such kind of demands in the uplink. That is a possible observation from these statistics, I think. So having said that, well, this is my every exercise in the global events. But yes, the traffic growth is very big. But depending on the cost versus value provided, people would use the new technology, new services or new technologies. And then the other thing is, yes, volume is being increased. The other one is maybe the nature of the traffic is different because of the IoT devices, or because of the new vertical services or something else. So volume and the quality is different from those in the previous release generations. That's our interpretation. Then, by the way, well, it's a quite simple chart. So what's the meaning of the peak data rate? Well, I'm talking about the peak data rate later on a little bit in detail, but it's quite simple. Wider means faster. I mean, wider bandwidth means the faster access to faster services. And every generation we have got faster peak data rate, and every decade these bigger files come into our market. Well, the extreme cases, for example, 20 years ago, we need, okay, that's a 3G generation. We need a few hours to download 75 gigabytes files, but if we utilize 5G radio access system, it will only 2 or 3 seconds. So this is the fact, and maybe this is one of the straightforward consequences of the wider technology. Then, well, I have been talking about the capacity improvements, so let me talk about something enabling technologies. So, oh, by the way, this is one of the other statistics I can provide. This is the number of the logical frequency bands specified in the 3GPP standards, and it's been increasing. So the first release, 99, was established in year of 1999. At the time, we only have few frequency bands in our standards. Then when LT started in this case, year of 2008, we basically copied the old bands in 3G to 4G. And on top of that, we introduced few new bands for LT. Since then, the number of the bands has been increased and looks saturated. Afterwards, we have started to implement 5G NL bands. But this time, what happened here is 3GPP hasn't imported all the bands for 4G to 5G in a straightforward manner, but they have selected some of, they exclude some of the, let's say, obsolete bands or something. But still, to me, as an implementer, it's a quite large number. And what happened to the carrier aggregation during the saturation period of the frequency band is this. So in LT Advanced, we have more than 6, according to my counts in the standards. Last year, we celebrated more than 600 combinations in the standards. It's enormous. Of course, there are some duplicated, physically overlapped bands. So implementers are very wise to implement all of these, some of these combinations into the devices. So that's the situation. And regarding the maximum data rate, this is the case for LT or LT Advanced in 3GPP standards. And left-hand side, you can see the UAE capability in terms of the maximum data rate. And the category 8 was one of the flagship category, which could provide maximally 3 Gbps in downlink. But actual tendency, you can see the market trends in this red arrow, which is, well, you are now in the category 10 or 11, I believe, if I'm right, at around few hundred megabyte per second in your downlink. Then right-hand side, you could see the parameters to get such kind of peak data rate utilizing 8x8 MIMO with RF frequency band of up to 100 megahertz. You could enjoy 3 Gbps peak data rate in downlink. And if it comes to a 5G new radio NR, there is no UE capability in terms of the peak data rate, but you see the only this simple or complicated equation on the upper side of this chart. And if you put the proper parameters, you'll see the maximum data rate per component carriers. And in this, in NR, maximum bandwidth of component carriers 400 megahertz. Then by introducing 8-layer MIMO, you will see almost 20 gigabps in downlink. In this case, actually it's 17 something, but this is the actual parameters defined in our standards right now. And variety of, depending on the parameters, you will see the different peak data rate in downlink in this case. So the idea of the NR is to utilize wider bandwidth and reduce by doing that, reducing the, what can I say, complexity of your RF circuitry. But still, there are some technical challenges like bandwidth of AD converter or DA converter in your transmitters or receivers, as well as the processing capability of your baseband processors. These are the technical challenges we are working for. I mean, they are working for to realize the 5G devices. Well, one additional point on the RF bandwidth is what we call fractional bandwidth, or you can say relative bandwidth or something like that. And this chart represents the ratio of the RF bandwidth to the carrier frequency. So horizontal axis represent carrier frequency, and the vertical axis represent the bandwidth defined in the 3GPP standards. And the left-hand side, you can see that the band, these factors for FTD frequency bands, and right-hand side, TDD bands are depicted both for NR and LT. And as can be, and these biased solid line represent ratio of bandwidth to the carrier frequency. And because of the technical nature, one of the limiting factor is the filter requirements. FTD needs a very steep attenuation in their uplink downlink gap, while the TDD in this case, limiting factor is basically, of course, there are some neighboring systems, so anyway you need a RF filter, and because of these natures, the ratio is at around 10% or something. Still, it's a big number to me, but anyway, these are the one of the limiting factor of the maximum bandwidth in our radio access technology. So, taking into account these factors as an example, my talk is going to ultra-dense network, which is improve the system capacity. Once again, I'm not talking about these technology in detail, but to save the time. But the idea is using the distributed antenna, and they are cooperated each other, or controlled by a single scheduler, and elaborate what we call virtual cell. So the idea is to, in this case, your devices are roaming around the area, and cell is following each devices to get the minimized interference. That would improve the system capacity and provide the higher capacity or density in certain areas. Of course, it's a very sophisticated idea, so we are working for these what can I say, innate technology enablers to realize. So, well, this is a part of the trials funded by our government. So you can see the acknowledgement. And as has been explained by some of the previous speakers from Japan, I didn't go through all of them, but this is one of the trials we have carried out in Japan. And, well, to use this distributed antenna and check whether it provides the enough what can I say, potential, whether it has a potential to provide improved capacity into our future networks. So you can see one of the outcomes of this work in a chart here. Yes, this is the one. Well, these are basic experiment, but we believe this is one of the basis for future work to improve our system capacity, in this case, enhanced MBB scenario. Then I'll leave this talk later on, because anyway, to save time, let me skip the talk about the latency, but anyway, there are some certain consideration needed to implement, what can I say, lower latency as well as massive MTC scenarios. So, having said so, let me conclude my presentation. Thanks for your attention. Gracias.
Thank you, Dr. Nakamura. So we have spared sometimes 20-30 minutes for open question. Of course, as you saw, we have really a solid panel of expertise competence coming from different kind of companies, entities, academia. So would you have any kind of question for our panel? Please, Luis.
Thank you very much for the presentation. It's really interesting. I have two questions. The first one to the TMV working group. As I understand, the purpose of the working group would be to identify and define network-related technological KPIs. Have you also considered incorporating or also identifying KPIs, technological KPIs, for the applications plus business-related KPIs? The second question goes to Mr. Wang from ZT. You have shown in your presentation that you have actually shown in validation testing that you actually achieved almost twice the target rate of density within a specific square kilometer. That is almost 2 million devices. How have you achieved that? Through extrapolation, or have you actually used 2 million 5G-enabled IoT devices to do it? Thank you.
All right, let me start from the KPI and the TMV. It's obviously the technical KPIs were our first priority. Business are a little bit more complicated. I know that all the ICT 17 projects are looking at them, and I'm not excluding at some point, if we have contributions, to include them. But right now, I would like to focus on having solid numbers on the technology.
Andrea, one comment on this. Just to mention that the KPI working group defines the various KPIs, technical and business. The TMV focus more on the methodology. Okay.
Okay, now I believe it's my turn to have this, more elaboration of the 2 million things, right? Okay. Yeah, this actually is not my first time being asked on this 2 million things. It was really interesting. One thing for sure is we are not able to make 2 million devices in this one to have a real tester. No, this is not going to happen. It's really expensive, Okay, actually, we did this in a way. Theoretically, you're going to have a test on how many devices you're going to support in this, 1 square meter by this site or this cell. And you know how many resources you're going to have, for instance, 20 or 100 microspan, and then you just take a small portion of the resource and do this experiment. For instance, you can, you can support 10,000, 20,000, something like that, and then you can do some calculation based in terms of a portion, something like that. This is basically what we did. Thanks.
My question is related to network slices. GSMA has what is called a generic slice template, and there are 40 plus attributes that can be populated by verticals. Any thoughts on how those, the generic slice templates can be mapped to KPIs, and how would we be able to validate those?
Okay, yes, we are aware of the various descriptor files that exist, as well as, for example, Tosca files and etc. We are taking under consideration all the templates that exist in order to produce a compatible and consistent descriptor files. I don't have a specific answer to give you, since we have just started on defining, but yes, we are considering.
To the question, if you present yourself, just to help also the answer for the panel. Are there other questions? So I have a specific question, because it's clear by the presentation, because we structure this kind of session based on the European point of view methodology and the results from other continent of the world. And of course, I mean, representatives from Asia are more focused on the radio part, the wireless access part, because is what is happening now in the world in 5G. More advanced work on the wireless part from Asia. So the question is how the end-to-end, I mean, is tackled by this working group or by initiative of the company. So really to understand what is happening, not only in terms of performance of the last stretch of the network of the end-to-end part. Please, Mr. Takaura.
Okay, thanks for the question. And I think in our case, 5GM today and yesterday, some of our colleagues from 5GMF have presented some of the outcomes of our trials or proof of concept. That is, that trials involve some vertical players, and to see what can our future 5G technology could provide them. So in that sense, my interpretation is we cooperate with our vertical players to see what would be the, what can I say, actual requirements from their perspective, and what would be our assets to be provided in the era of 5G. And throughout these activities, we believe we could establish a certain common KPIs with our vertical players in the end.
Thank you. Please, on the right. Please introduce yourself.
Yeah, hello. Mansour Hani from Ofcom, the regulator in the UK. I think in terms of the KPIs, it's very interesting presentations, and on the business side, so these KPIs need to be matched to service level agreements, which can then be sold. So have you any thoughts about how could that be implemented in a way that's commercially viable? And I'm very interested in particular on the potential of smart contracts to implement smart SLAs in a very dynamic way that matches the real-time requirements of 5G, for example.
Yeah, I can take that. I think this is exactly the point, and this is what I tried to address in the presentation also, and it was mentioned as one part in the motivation. Eventually, the goal is to derive SLAs, but by first providing to the verticals certain tools that at this phase they will help them, let's say, validate, assure, or let's say diagnose what goes on in the infrastructure up to a certain point. But the end goal is exactly to deliver the SLAs. Now, with respect to smart contracts, of course, this is something going beyond the TMV and the context we're discussing here, but for sure, I think there is, with this heterogeneity that the system has, I think there is a lot of room to attribute the system somewhere with these capabilities. Also, in order to answer Mauricio's question, I think the end-to-end is very critical for the vertical. I mean, only restricting to a certain segment doesn't show much. And I think it is part of TMV and of EVE to somehow decompose the network into segments, again, going up to a certain level of detail, and of course monitoring what goes on per segment in order to be in the position to make the diagnosis. But the end result is, you know, the vertical performance, what the vertical sees, and perhaps some suggestions on what to improve.
Thank you very much. Any other question? Please, on the right.
Hello, thank you very much for the very interesting presentation. My name is Manuel Tarazona from European Investment Bank, and my question is about energy efficiency, because only the colleague from CTE has mentioned this in the presentation. So I will have two specific questions, one for the colleagues from the 5G PPP. So is energy efficiency, network energy efficiency in particular, included in the metrics that is being considered in your projects? And the second question for the KT colleague, you have already a real network working. How does the energy consumption of that network compare to your 4G network?
Related to the TMV, I agree with you. Energy efficiency is important, not only at the device side, but on the network side, because it's an expense for the operator. That said, the TMV relies on contributions and experiences of the different 5G PPP projects. At the moment, there is no specific project addressing that KPI in the group. We are obviously welcoming everybody who's bringing that onto the table, because we all believe that should be included. And as soon as there is a project addressing it, I will be the first one tackling it to get it on board.
As you see in the KPIs announced by the ITR, the energy reduction is also very key KPIs. But as you may know, the 5G network adopt new technology such as massive MIMO, and some more RF component is including the 5G network. So I'm not sure the exact the energy consumption of the 5G network compared to the 4G, but I guess that the energy consumption is more than the 4G network because of the new technology.
Yeah, just to add on this, because as you understood, now the program of 5GPP started from the research results, now building this kind of platform, this methodology. Now there is the new wave of project that started the 1st of June of phase 3, where I saw many energy consumption, goals and KPIs. So this is the last phase of this program, and because we are going to the market, I saw that this kind of KPI is included in this new activity, but they started the 1st of June 2019. So of course, just a presentation of aim and challenge and not results.
I agree with that, the moderator. This is the start of the 5G commercial. So we have to some high technology in the 5G base station. So reduction of the energy consumption is a very important role in the R&D side as well as the industry side.
Thank you. So I guess that everybody now is ready for a very nice and exciting part, and so I would really thank the presenter that did a very, very good job on this subject.
And also, obviously, thank you to the moderator for a very innovative session. I hope it was of interest. Just before you leave, that's the end of the global event. Thank you very much for taking part. I'd like to just finish by thanking everyone behind the scenes who has helped making it all possible. It's very much appreciated. I'd especially like to thank Alexandro, our head of office, if you'd like to stand up, please, who has been doing... who's been working at least 25 hours a day the last few weeks trying to put this all together, and thank you, sir, I appreciate it. So thank you again for all participating. Have a great trip back if you are traveling back today. If you're not, enjoy the rest of the conference, and I hope to see many of you at Shanghai next year for an exciting session there. Thank you very much.